Welcome, everybody. We're thrilled to have you here today for our live demonstration on needle sharpness and syringe actuation testing, with a particular emphasis on compliance with 21 CFR Part 11. But before we dive in, there are a couple of housekeeping notes I'd like to share with you. Today's session is brought to you by Mecmesin, a proud member of the Physical Properties Testers Group, or PPT Group for short. PPT Group is a collective of leading brands in the field of physical properties testing, offering a wide array of solutions for tensile testing and compressive strength, torque testing, textile testing, and the effects of shock and vibration, amongst other parameters. And our sister companies within the PPT family include Lansman, James Hill, and Telluris. For more details about the group or any of our brands, please visit the PPT website. We've also shared a link to our events page in the chat box for your convenience. But now focusing on Mecmesin, we have established technology labs in the US, UK, and Asia, dedicated to supporting our customers with education, proof of concept, and demonstration testing. Should you have any specific needs in physical properties testing, our global team is at your disposal to provide the assistance you require. And let me introduce the team for today's webinar. Moses De Rocha will be our presenter, and I'm Sharon Smorenberg, one of the coordinators. Additionally, we have support staff stationed across Asia, Europe, and the Americas, ensuring that no matter where you are, we have a local expert ready to support you. We're aiming for a dynamic and engaging webinar, therefore we encourage your participation through questions. Feel free to submit any queries you have at any point during the webinar using the question box. We will address these questions during the Q&A session at the end. The webinar, again, as always, it's being recorded, and the recording will be sent to the email that you'd registered with, allowing you to share it with colleagues or revisit it as needed. But now, without further ado, let me hand it over to Moses.
And thanks, Sharon, and thanks everyone for making the time to join our webinar today. So this is the logical continuation of our last webinar, which was more of an introductory webinar where we touched on the various capabilities for Mecmesin under the PPT umbrella for medical device testing, especially as it relates to 21 CFR Part 11 compliance. And the next few webinars are going to cover into a little bit more detail, and also we'll have some live presentation of what the actual testing looks like for today. We'll be addressing needle sharpness and syringe actuation, or the break, loose, and glide as you know it. And the next ones will be looking at child-resistant closures and so on. That way, at least we cover all of the areas that we touched on in our previous introductory webinar. So a real quick primer. I know that every time you, especially for you in the pharmaceutical and the medical device industry, when you hear the term testing, it means something slightly different. In the context of physical properties testing, this really refers to force testing. This could be either tension, pull testing, or compression testing, in which in this case, based on what we'll do today, we'll be looking at. So as far as medical device testing is concerned in our field, it's not a chemical or biological test. It's not supposed to diagnose or treat any kind of illness or sickness or disease. It's essentially a non-medical physical properties testing of these medical devices on how they perform once they get to your patients or the consumer. So that's what we'll be looking at. So when we say testing, we're looking more at more of a physical properties testing. In this case, needle sharpness is a type of compression testing, and the syringe plunger actuation is also a type of compressive force testing. So that's what we'll be looking at. I just wanted to put that out there. That's important. So today's agenda, we'll be looking at overall at the importance of medical device testing in general. And then we'll take a closer look at the syringe actuation testing, which is the break, loose, and glide force as you know it. And then right after that, we'll do a quick live demonstration of what the test actually looks like in real time. Now, even though we may be citing the ISO testing standard. For purposes of our webinar, we'll just move at a slightly slower pace so we can properly demonstrate the different aspects of it. Now, understandably, every industry has their own way of testing depending on the product design, syringe cylinder sizes, and so on. So all of these testing standards are more of a guide than anything. So we'll be trying to kind of check off all the different boxes of all the different components that make up the testing application, all the important components. So at least you're compliant, either partially or as a guide or fully compliant with the test standard. We'll do the same thing for needle sharpness testing. We'll do a live demonstration after that. And then we'll also look at the software's compliance with 21 CFR Part 11, as far as the testing software, which we will be using today, which is our flagship Vector Pro MT software. And after that, we'll open the floor for any questions, concerns, suggestions, commissions, omissions. That way we can keep the session lively. So without further ado, we'll look at, in general, why medical device testing is important. Now, these are usually in 4 areas: for research and development to determine product viability, the strengths and weaknesses of products before they get to the production stage, and also for quality control, for establishing certain ideal product standards for quality and safety before the products reach the consumer or the patient. And then in production, it's essentially to maintain whatever preset ideals in that quality control part in production, to maintain those standards, to make sure all products leaving the factory floor are compliant with your own internal or industry set standard. And then sometimes also for supplier audit. For companies that do not necessarily manufacture their own medical devices, when these devices come to you, they come with a report that says, oh, you know, we've done the break loose and the glide force testing on it. Here are the values. If you want to audit those values to make sure they actually do meet those ideal standards set by the manufacturer, you can also perform these tests to make sure the numbers line up with what has been provided. So these are the main important reasons why medical device testing is important. Now, the role of medical device testing in everyday life goes from, you know, a matter of just simple product quality or some matter of inconvenience, you know, where in determining the ideal needle sharpness or the ideal break loose force or the ideal glide force. Now, all of these are abstract until they actually make sense to a patient, where if the needle is too brittle, it might break, or if the needle is too thin, or if the needle is too soft, it might bend, or if the syringe, the syringe actually offers too much coefficient of friction, then it's going to be a little bit more difficult to dispense any kind of medicinal substance, which then might cause that discomfort to the patient, and which again opens a can of worms as far as the liability issues that are kind of follow. So you don't want dull needles out there, because the key is to be able to inject a patient with as little pain as possible. I know that's always my personal preference, as quickly and as painlessly as possible. I don't even want to know the needle was ever there. So these are some of the factors that surround the process of coming by that value that you consider ideal, as far as an ideal sharpness value, an ideal break loose value, an ideal glide value. So again, it could be just a matter of product safety, or it could be a matter of product quality, or a matter of safety, as in how much discomfort is this product causing to the patient. Again, in an ideal world, you want things to be as smooth and as painless as possible when a medical professional discharges or injects a patient. And you don't want your name to come up, because anytime anything comes up, your brand's reputation is on the line, and so failure is not an option. So this, again, is the reason why you do want to test, to maintain those quality and safety test standards. So now we'll look at what the syringe actuation testing is. Now, you hear it referred to as syringe actuation, you hear it as a syringe plunger test, you hear it as a break loose and glide test, which I think is more commonly used in the industry. Now, what that essentially represents is it's a measurement of the force profile associated with expelling fluid from the syringe barrel. That profile refers to that break loose part, which is that peak force. So when you start pushing the plunger through the syringe barrel, there is an initial break loose because the rubber at the tip of the syringe plunger kind of catches on the plastic, and you need to get past that. And then the glide force essentially is that average force where you continuously push the medicine or the liquid out of the needle or out of the syringe as necessary, depending on the type of medical delivery system that's being used. Now, this test can be performed on both empty and pre-filled syringes. So just as an FYI, and this is again in adherence to ISO 7886-1 testing standard. The ideal testing equipment that's usually used is a motorized computer controlled tester, the syringe actuation fixturing, and obviously the testing software. Now, the testing, all the combination of all of these allows for repeatable and consistent testing. That way, each operator is doing the exact same thing at all times, and there is not too much variability in the actual test results that are generated from these tests. So we will look at each of these components in the live display here in just a second. So if you give me a second, I will switch to my webcam and kind of walk you through what we are using. So if you can see my webcam, so this is essentially our setup. Now, again, the test requires 3 items. 1, the motorized tester, the fixture, and a plunger. The plunger is essentially just a compressive plate that pushes against the actual plunger that goes through the syringe. And then the base fixture accommodates different types of syringes depending on the size. In our particular design, what we have is a universal base fixture, and then there are die inserts that actually accommodate the different syringe sizes depending on however many different sizes the manufacturer or the producer has to test. In this case, we created a die that fits the sample fixtures that we will be using for this particular demo. So that is our syringe. Take that out of the box here, and then we just slide that through our die and simply insert that. One of the other things we'll do as part of the setup is to bring our compression probe up just so we can pull the syringe to a point where we are ready to start the test. So this is technically all there is to the test setup. And the goal here is to get all operators to do this thing the exact same way. No guesswork involved. It's very simple. Everyone's going to do it the exact same way each time. And that in itself enhances the testing environment so we can generate repeatable and consistent testing results. So once the test is set up, the entire action then goes to the testing software, which I will be sharing here momentarily, and we'll look at that as well. So if you still have access to my screen, this is our Vector Pro testing software. So a few things I'm going to quickly touch on because we'll also touch on them in the 21 CFR Part 11 part. We'll start with the permissions tab, which again, the statute calls for very strict user access controls, including password complexity, as in how complex you want user passwords to be. And we have policies that allow you to dictate the maximum number of characters required in a password, how many uppercase letters used, or how many lowercase, or how many different numbers are used, and whatever you want to add a combination of non-alphanumeric characters and symbols and so on. So you can get a combination of, let's say, a 16 character password. We need a minimum of 4 letters, a minimum of 4 uppercase, a minimum of 4 lowercase, a minimum of 4 symbols, and that essentially makes up your 16. And again, the key here is to make sure those passwords are not easy to guess in order to enhance that security and the data integrity. There is also a password aging that allows these passwords to expire over a certain period of time. And again, that's something that the administrator can set, whether it's a 30-day password expiration or 60-day or 90-day, at the end of which each user can then either reset their password, or they have to go through the administrator to get the administrator to reset their passwords for them. Again, sticking to the same theme of security and allowing as little password breaches as possible. And then there is a lockout feature that allows an administrator to set how many different attempts at guessing the wrong combination of username and or passwords before a user is locked out. There are additional policies for what happens after a user is locked out. Is the user allowed to reset their own password, or do they have to go through an administrator? That can also be set up in the test system. And then finally, there is an idle lockout. So again, if data integrity is a thing and it's important, then you don't want your operators having a batch of 20 tests sitting there while they take off to lunch and leave the screen just sitting there. The administrator can set it up so after 5 minutes or 10 minutes of inactivity, the system will log the user out. And that inactivity simply refers to either no tests running at the time or there's no mouse movement on the screen. That's when the system considers the inactivity, and then it will log this user out. That way, no data is compromised by anybody walking to the PC and accessing data that has already been generated. There are also different levels of users. So you can set up either groups of users or just individual users. It always starts with setting up individual users, and then you can create different groups like QC, management, groups like production team, groups like first shift, second shift, third shift. So when you go in to assign permissions, those permissions can be assigned to either just the individual users or to a whole group. So for instance, if you want to make sure the night shift only has access to the tests that are not sensitive, you can redact all the permissions to that particular, all the users in that group and say, hey, this group can only access test A, test B, and test C and nothing else. So when they log in, those are the only tests that they'll have access to. So setting up users is just very simple. Just click plus, enter a username, enter a password. And then I did mention previously the options to have a user either reset their own password or have a password emailed to them if they forget it. Now, if you leave both of these policies turned off, they always have to go through an administrator to get their passwords reset. So that's essentially what this part of it represents. And then once you set up a user, you can also set up an additional group, assign these users to those groups, and then the next logical step is to go into permissions and determine what those users can or cannot do. For example, do all of these users and or groups of users have access to all the tests on the system? Can they access the archive? Can they create attributes? Can they create batches? Can they even copy an existing test and make a different test? Can they delete a test if they finally they recognize there's an anomaly in the test? Can they have access to the audit trail or the event log? Can they create new tests? Can they override the versions and so on? So there are different types of permissions that can be assigned within the system on what users can or cannot do in the software. Okay, I'm going to back up one step. All right. There are also languages that allows our software to be translated into one of 9 different languages. Let's say these days it's a global economy. You might have a sister company out in Japan that comes to visit and they'd like to run tests in Japanese. You could do that in the languages. That's not part of our demo for today. I just wanted to touch on the different components of compliance with 21 CFR Part 11. So the crux of that statute is the audit trail or the event log. Now that event log will record above and beyond what the statute actually calls for, which is the creation, modification, or deletion of any data. So we look at capturing every single thing a user does in the system. So for example, I just clicked on that event log. It records the date and time and which user was logged in when that particular action was performed. And you can actually filter through these rewards by querying the database, querying the actions on a particular date, querying the actions for a particular user, querying the actions for a particular test, actually even querying the actions for a particular command. Like for instance, if we wanted to find out any user that clicked on the the delete function, we can narrow it down to that, or to a targeted command in the test. How many users clicked the run command to run a test? So all these different facilities are available to an administrator. Now, by default, the audit trail is only accessible to the administrator. Now, it's up to the administrator at the time of first use who they decide to assign permissions to. So once you've determined all of this, you have additional parameters where you can export the data to text. You can email it to any number of recipients separated by commas, or you can simply print to your network or local printer, or just print to a PDF driver, which creates essentially a PDF report using the inbuilt PDF driver that comes with the software. So this is the audit trail, which plays a really critical part of the test. Now, as far as the test procedures themselves, you see I've already configured the 3 tests here for purposes of our demo. You can associate specific images to those tests, so when an operator logs in, they know exactly what the test is. You can use a description of an ISO or ASTM test standard to kind of narrow down what the operator is about to test. And if you look on the top right of any of those thumbnails, you see the V1, which indicates a version 1, that initial version of the test, which means if we went in now and we decided, you know what, we want to run this break, loose, and glide test at a slightly faster speed than whatever we set to in version 1, when you go to save it after making that change, the system will prompt you to create a version 2 of the test for purposes of batching your data in all the test results generated using version 1 of the test, which is say 5 inches per minute speed, and then version 2 of the test, which is at the slightly higher speed of say 10 inches per minute of the speed. Or if you are an administrator or you have permissions to do so, you have an override third option that actually overwrites the existing and saves all of your changes to the same version 1. That way all of your test results are batched under the same version. So other than that, by default, the system will always prompt you to create a different version anytime you enter the test parameters and create make any changes or make any modifications to an existing test. Let's take a quick look at what a test configuration looks like. We'll start with the syringe, break, loose, and glide. So when you go in, this is the test that's already been configured. But when you start, all you do is give the test a name, indicate which tester it's going to be used for. Again, either use a webcam that's attached to your laptop or PC or tablet PC, take a picture of this sample, or you can just browse for whatever image you're looking to use in the test, which associates the image as an attribute to the test profile. You can also create test notes to indicate what capacity load cell needs to be used for this particular test. So when you look at the test overview, any operator will know exactly which load cell capacity to use, because there are applications that require higher capacity load cells because they might require higher forces. And then there are applications that are very minimal that require lower capacity load cells. So you'll see that in the needle sharpness example as well. I'll jump over specimen, which is usually reserved for materials testing, which is not the subject of our webinar today, to operations. In the operations timeline, this is where you define your test procedure. Now, whether you're configuring an ASTM test standard, or you're configuring an ISO test standard, or an in-house standard, or whatever custom standard, any combination of our common commands. Now, depending on whether the test is a pull test, a tensile test, or a compressive test, or a 3-point bend test, or a coefficient of friction test, any number of these icons, first they'll change depending on the test profile, and then you can select any one of these will also have the tooltip that indicates what that command represents. So all the user has to do is essentially drag and drop these into the timeline to populate the test configuration. So if you look at my timeline here for the test, I'm saying to first zero everything. If you look on my screen, we have a residual load of about 0.018, and we're looking at sitting at about 90.8 millimeters, even though we're asking that test to go to about 44 millimeters. So if you try to run this test, it's likely going to trigger an error. And so we obviously want to tear all the values before we start the test. We also have that touch on, as it says here, apply a touch on load to the specimen. So the test technically does not begin until that upper compression plate comes down and makes contact with the plunger surface. So we're using a very minimal force of about 1/4 Newton to apply touch, zero everything once again, and then continue to push the plunger to 44 at a speed of 250 millimeters per minute, which is technically about 10 inches per minute. Once that test completes, we want the plunger to return home, and that allows the operator to remove the tested sample, put another one in, hit the start button, and then test however many samples they need to test in the batch, whether it's 10 or a dozen or 200. On that right side, you also have a few additional options here. First, we start with the sampling rate, and that's user selectable from 1 sample per second generated to 1,000 samples per second. Now, the difference in 10 hertz and 1,000 hertz in running a 30-second test, it's whether you're generating 300 data points or 30,000 data points. So that all depends on how much data you want to generate in your test. And then there are additional selections for your time units, and that's minutes, seconds, and milliseconds. Force units can be millinewtons, newtons, kilonewtons, kilograms of force, ounces of force, pounds of force, grams of force. And your displacement unit can be millimeters, inches, microns, centimeters, meters, feet. And then your speed units will be microns per minute, millimeters per minute, centimeters per minute, inches per minute, microns per second, millimeters per second, and so on. And then obviously for applications that require the graph to be plotted on a stress versus strain curve, you have stress and strain values from megapascals to kilopascals and PSIs and so on. The next step, now that the test has been configured, is to pretty much determine what goes into the test report. Now, these, if you're testing to a testing standard, whether it's ASTM or whether it's an ISO standard, will determine what kind of data you're generating. So for a simple break, loose, and glide force, what we're looking at is that initial peak force. Now here are all the different calculations that are available by drag and drop, whether it's an average or a slope or an area under the curve or a break or multiple peaks, whatever the case may be. In this case, we're selecting that max at the beginning of the test. So once you find that max, drag and drop into your calculations field. The additional parameters allow you to name the test result, determine what your XY axes look like. This is going to be on a load versus displacement. We want to make sure the result is a load. In this screen, you can also apply your results to pass or fail criteria. Which essentially determines whether your test results for the break loose meets a minimum standard. If you want to have a minimum, just enable minimum. As long as it meets the minimum, that's great. Or if it meets it does not exceed a certain maximum, which means if it exceeds that maximum value, then that means it's too tight or too stiff, or there's too much friction in the barrel, and so on. Or in most cases, you can create a range where you say any result that falls between 3 and 5 newtons, that's perfect. Anything below is too smooth, anything above is too tight, and so it will show up with a red X as a fail. This can also be done after the fact and applied retroactively to your test results. So for now, we'll uncheck both of these. And then once that initial max or peak value, the break loose, has been acquired, now we want to generate our average. Now what we try to do is to generate that average or the glide value after that initial peak has occurred, so we do not include that initial spike in the test result. So we're generating this from between 6 and the 35 millimeters, or I'm just actually going to make this 40 for now. right? Between 6 and 40, that's where we want to generate our average or our glide value. That's when you're actually pushing that medication through the barrel after that initial break. So these are the two test results that we're generating here. And then if you want to create test reports, there are different report templates that you can use. We've opted to use template number 11, which already has a report title. If you're a company and you're testing these for a particular customer, you can actually select then put their logo on the right side, left side, wherever you need to put that. You can also change what your graph looks like as far as where on the XY, whether it's a load versus displacement or stress versus strain or load versus time or whatever the case may be. So once this is done, there is a final step. Let's say this is a really critical application that you only want administrators to have access to. You can, besides above and beyond the system-wide permissioning system, you can also assign permissions to this particular test on who has access to this test. So anyone not in any of these boxes won't even see the test on their dashboard when they log in, because it's such a critical test. So once the test is configured, you go to exit. I did mention the versioning system. As you can see, the system has prompted me to save changes. If I click yes, it's going to save a version 2 of the test, just based on that little change I made in the range where we want to select our glide force. But as an administrator, you can simply use the override version. If you are a regular user without the appropriate permissions, that override version will not be included. So you will be forced to create a version. And then if you need to include any reasons or notes why you made the changes, you can include those here. So an administrator can go in and say, okay, why did we create a version 2 of the test? You can look and say, you know what, 5 inches per minute was too slow, so we decided to increase that to 10 inches per minute, or whatever the case may be. For purposes of our webinar, I'll simply just click the override version, and that will bring us back to the main screen. So that's essentially what the test configuration looks like. It's kind of going to be the same for all the different tests. The parameters might change just a little bit, and so on. So without further ado, once you've logged in, you just click on the configure test, and that brings you to the main screen. I'm just gonna lighten the screen a little bit, change the contrast so we can see the traces a little better. At this point, everything is already set up in the tester, and all the operator has to do is set a home position so we know where the crosshead returns to at the end of the test, and then subsequently push the start button. So the plunger is going to come down, is going to touch the surface of the plunger, and then it's going to push that all the way to about 40 millimeters after touch. It's going to retreat back to starting position, which will allow us to remove the tested sample. And then we'll put another one in. For purposes of our webinar and for time, we'll only test a couple of samples here. So this is the test. Okay, the test has completed. Compression probe returns to the home position, and that allows the operator to remove the tested sample. We'll put another one in. It's a new one. Oh, that's all right. We'll drop the needle, but that's okay. So that's all there is. In seconds, we are already there. I'm going to run a second test here before we look at what the actual test results look like. So this is our second test. It's essentially going to repeat everything we did the first time. Now, in cases where you have a pre-filled syringe, you obviously will have a beacon or a cup at the base to catch the liquid when it's dispensed from either the syringe or the needle. In our case, we're just using an empty syringe, so we don't have to worry about that. All right, so that completes the second test. So now if you toggled from the graph to your test results, you can now look at your calculations. So test number 1, it's catching that peak break loose value here at about 4.5 newtons. As you can see, it's right there. Let me change the contrast a little bit so you can capture it. So about there. And then the glide force, we did ask for it to capture that over an area here between 6 and 40 millimeters. So that's where it's capturing the glide force, which is about 1.7. And on this second one, again, these results are not written in stone. It's more of a proof of concept than anything. It did see a slightly lower break. And so that's going to be right up here, which is about 2.1 newtons. Now, these are syringes I've had forever, so these results are not written in stone, forgive me. And however, the glide force, which is also equally just as important, is about, around the same, 1.7, 1.8 within that same area. So these are the different test results that we just got from our first 2 samples. Again, you have additional options for exporting this data to Excel, either as the raw data and or the actual test results. You can send these to a CSV file, or you can email any number of recipients separated by commas, or you can just create a test report based on our report template. So this is a syringe break loose and glide report. This is a load versus displacement test. Test number 1, break loose force. Glide force, test number 2. It also gives you some additional statistics here, the mean, standard deviation, your minimum, maximum, and then it kind of shows you a graph of what's what. So you can essentially just print to a local or network printer, or you can just use the inbuilt PDF driver to create a PDF test report. Now, test number 1, you can also click that to create some additional notes here. We'll just say, hey, this was a new syringe, and we can say the second one is an old syringe, and that's what kind of explains why the results for, especially on the break loose, are slightly different, or whatever the case may be in looking at the graph. So if you had to assign pass or fail criteria after the fact, when you click on any calculation, you can now assign that pass or fail. So if we said any result between 3 and 5 is a pass, that's all we do. Once we exit, it will indicate what's passing and what's failing. So obviously the first one would be passing, between 4.5 is between 3 and 5, but under 3, it's failing. Now these results are generated automatically as soon as the test completes in real time, so you can pretty much know what's passing, what's failing. I always use the 80% rule. If 8 out of 10 samples are passing, you're happy. If 8 out of 10 samples are failing, you're not a very happy person. So, but you'll be able to tell instantly as soon as each test result completes. All right, now I'm just going to exit. Now it's also asking for an override for the reason that we now applied the pass or fail criteria to the test profile, which will then be retained for subsequent testing. So if I say no, we'll just bypass it and always do it in real time. If I say yes, it will create a version 2, which now includes pass or fail criteria, or we can just override and keep the new changes all within the same version of the test. So that is essentially what the break loose and glide test looks like. Now, I'm going to go over to the syringe, the needle sharpness testing, and we'll come back here momentarily to the live demo. So needle sharpness testing, again, this is going to be in adherence to ISO 8362. It is simply the measurement of the force required for a hypodermic syringe needle to pass through the elastomer cap used to seal a vial and also to pass through the skin. So that's it. Now, in an ideal world, most parenteral drug products are manufactured in glass vials or phials and sealed with an elastomeric rubber stopper and a crimp cap. It is critical for the syringe needle to penetrate this cap to extract the product while maintaining the appropriate sharpness to subsequently inject a patient. So there are two types of tests. One is the cap, and the second one is skin. So you can either do this in one test or you can do them as separate tests depending on how you're testing them. I would want to say the medical professionals would want to test using the skin simulation, and the elastomeric glass vial bottle manufacturer would be testing the caps. But both of those use the same testing standard. Once again, we'll be using the same tester, slightly different fixtures. Now, the needle puncture fixture is where it gets creative. You can use all types of simulated fabric, simulated latex, rubber, simulated skin, which is what we'll be using here today. Now, this is essentially what nurses use in training to learn how to inject, how to treat sutures, and so on. And then obviously the testing program, which we have previously looked at. So I will go over again. If you all give me 20 seconds to change the fixturing. I'm also going to change the capacity of the load cell being used. I should probably put the, let me actually turn on the webcam so you can see how easy it is to change from one fixture to another. Okay, there we are. So this was the fixturing. We're just using some thumb screws to hold the fixture down. Just going to remove that, set that back here. The second one is a little bit more creative. So this base fixture has a multi-purpose base fixture that expands and contracts depending on the sample diameter, sample thickness, sample width, and so on. So what we'll do is we want to make sure that the silicone rubber fingers you see on the base, they are a non-slip material to prevent the samples from either lifting or sliding or slipping during the test. And one more thing we will do is just going to lift this up a little bit and go ahead and remove the 100 Newton load cell. And then we'll slide on our 25 Newton load cell, which is a lower capacity load cell that was designed to be a little bit more sensitive. And we'll just lower that. So on this load cell, there is a plunger and with an attachment. It's a lure attachment that allows us to essentially just screw in a needle just as we would a syringe. So that way you use one universal fixture for all of the different needles that you will be testing. So what I'm doing here is just simply using the wheel to bring the crosshead all the way down to a point where it's close enough to the fixture. And here we go. So there are some alignment issues that need to be taken care of. So the first thing I'll do is just insert our needle, screw it in place. There it is. And then I'm going to move right there to the center of the cap and just tighten everything down. So that is all. That's all there is to it, pretty much. That is our test setup now. We'll just tighten the load cell, make sure there's no movement. And now the test is ready to go. Next thing we will do is go back to the testing software. And this is the test we generated. This is a needle sharpness test for the caps. Again, to go over the test very quickly. It's very similar to what we did. There was a test, again, as you see here in the test notes, we've determined that we rather use the 25 Newton load cell to kind of alert operators to use the appropriate load cell capacity. In the operations, very similar. Once again, we're using a very minimal touch-on force. Good idea. Plug in the load cell. There we go. See a few more zeros. There we go. Okay. And it's a 0-all run to a touch. Let me just increase the touch a tad bit that way. it's not ultra sensitive. And then it's also, this time, it's only going to run it to 6 millimeters, which is all we need for the penetration force. And then at the end of the test, we want to return home. The units of measurement remain the same as the last. And this time, we're also looking for, again, we're going to call this, instead of break loose, we'll just call this max force. And we'll call that the average. That's it. And that's all there is to it. We've already selected our report template. We already assigned our permissions. That's all there is to the test. We'll override the version. And now the test is ready to go. Now, the cool thing is, once you configure the test for all future subsequent testing, all the operator has to do is come in and select the test. It goes in. We're going to change the contrast a little bit. There we go. First thing we'll do is set the home position so the system knows to return to the appropriate proper position where it will return to at the end of each test, and then run the test. So it's going to come down. Here we go. Oh. Okay, so I'm glad it did that. So we've missed one step, did not tighten on the base fixture, but that's okay. That should at least allow us to demonstrate one part of a missed test. SOPs indicate that we need to tighten down on the fixture to prevent it from moving. So here we are. That was test number 1. We're going to run test number 2. Once again, I apologize, but in an ideal testing environment, what you do want to do is test different needles. For purposes of time, I see we're getting close to the hour mark here, so I'm using this the same one as a proof of concept. So that's test number 2. So these are the 2 tests so far. So if you go into our max force, that's our first max force, about 1.4 newtons. Our average force. Now, the reason we're not seeing any values on the average force, I'll explain, is because the test is calling for it between 6 and 35 millimeters, but we actually did go only up to 6. So we'll just say between 3 and 6. And you can change all of these in real time in order to generate. So as you can see now, we do have values that, again, that applies retroactively to all the different samples. So that was the second test. So this is a test you would do on the cap. Now, if you wanted to use this on simulated skin, this is where it gets to be a little bit more fun. So first thing I'm going to do is just raise our needle up just a tad so I don't poke myself. I'm going to remove that. And this is something you can get on Amazon that I did mention. It's a simulated skin that you can use if you don't have to call on some of your employees to be volunteers for this test. This works just as well. So we'll just put that on and just open that, and it just grabs that once you open it to keep it static. So, there we go, nice and solid. And we're going to bring this down just a tad. Okay. And the cool thing about this particular fixture, or this particular sample, is you can test on different surface areas for all the different needles you have. And so you're not just testing just the one part and then throwing it away. So it kind of creates a little bit of an advantage. So I'm going to go back, say override version. And we're going to call up the particular test for this. It's very similar to the one we just ran. So, okay, here we go. Because of the slightly different home position, we're going to change that as well and run. So again, it's going to touch on. That's it. All right. I am going to move to a slightly different position. There we go. And then run that again. All right, so those are the two tests completed. So once again, this time I'm gonna go a 0 to 5 because of the test profile. Here we go. So yeah, it still has a slightly different average and max. Now, again, these are just terms that I'm using. You can name them anything, any description that actually meets your own internal testing standards. So again, our max is around 1.6 and it's about 1.9 on the second one. Now, what I am personally suspecting is that because the layer is slightly thin, it may start spiking as it gets to the base. But again, this is a proof of concept to show how you would measure these. The key is obviously to pick a material and stick with it to maintain consistency. So again, there are additional parameters for the ability to export your data, create testing reports, and so on. And that pretty much is what these two tests look like. I'm hoping for some questions on the other end of this. All right, let's go back to. Okay, so again, so having done that now, hopefully having the opportunity to show you the parts of the software. How do we ensure data integrity in FDA-regulated industries? So VectorPro's compliance goes a little beyond everything I've just shown you in the demo to a few things here. The major things are the audit trail, as I mentioned, a comprehensive event log, which automatically records all actions and changes throughout the entire testing process. I did mention the versioning. Test changes are saved each time the test is modified from its original form and a new revision or version is created. There are also electronic signatures, which VectorPro keeps an electronic signatures approvals feature, which replaces the need for manual or hard copy signatures. And then there is also an Active Directory that allows the software to be operated locally or via a company network, where this, you can integrate the software into your company's domain and a common IT policy set for all users. And then finally, there is an SQL server. By default, data from VectorPro is stored in a local database on a PC, but for enhanced security, there is an option to install Microsoft SQL Server, and that's available to purchase as an add-on module. If you'd like to get the full list of features and capabilities in compliance to 21 CFR Part 11, you can just take a picture of the QR code on your screen, and you should be able to access a PDF that has all the different levels of compliance of the software. And with that, turn it back over to Sharon for our Q&A. Over to you, Sharon.
Thanks so much, Moses. So one of the first questions that came in is, can I assign a serial number?
Yes, you can assign a serial number. Now, I still have the software open. I'm gonna go back and show you. So, and let's say if you wanted to do that for your syringes, right? You could go in to edit, and then we're gonna take that little icon here, the attribute that says number, and we'll call this serial number. Click OK. Now, whatever that serial number is, you can either prompt for the value. Actually, let me back up just a second real quick. Let me use note instead. Here we go. Say serial, because the initial feature that I just activated allows you to assign one number to all of the samples. If you wanted to individually have an operator manually enter a serial number, this is what you would do. Is we're gonna call this enter serial number. Now, when you do that, you can either have the operator enter it before the test, or at the beginning of each test. And the reason you're seeing all of these grayed out is because we've already generated results with this particular test, and so it doesn't allow you to. But at the beginning of the configuration, you'll enter it to generate to say, hey, enter this value before the test, and that will, when you hit the start test, the first thing it does is pop up and prompts the operator to enter a serial number, and then once they enter that serial number, it will continue over to the test. That way, each sample tested is assigned its own unique serial number. Right, back to you, Sharon.
Thanks, Moses. There's, I think, time for one more. And the next question is, does it make a difference what material is used in the needle sharpness test?
Excellent question. Not necessarily. The key here, and most physical testing is just looking to simulate what happens in real life. But my advice is always pick a material and stick with it. If you're testing the elastomeric caps, you can buy a ton of those to simulate the test, or you can test the actual product. When it comes to finding something that simulates skin, there's all kinds of options out there. Some are just rolled latex material. You can find what I just used here. But once it makes sense to pick one and always use that instead of just jumping from one material to another if you're looking to maintain some consistency in the testing. Back to you, Sharon.
Wonderful. Thank you, Moses. I think with that, we're gonna draw it to a close. If there are any further questions, or if you would like some clarity on something else, then please don't hesitate to reach out to us. You've seen the email info@mecmesin.com and moses.derosha@pptgroup.com. Feel free to reach out to us at any time. Thank you again for your participation today. We will be sending you a recording of the webinar, and yes, have a lovely day, and we hope to see you on one of our next webinars.
Thanks, everybody.